Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. I'm going to show you classification of stationary points, where is local minimum and where is gonna be a local maximum. Have a look here. If first derivative is equal to 0 and the second derivative is greater than 0, which means a positive, then f has a local minimum. Have a look here. This is a graph, and this point is a local minimum by the turning point because a smile parabola, smile graph. So you can see the second derivative is positive because this is a second derivative, and at this point first derivative is equal to 0. At this turning point is a local minimum. Now the second, must remember, if the first derivative is equal to 0 and the second derivative is less than 0, then f has a local maximum. So this is a local maximum, sad parabola, sad graph. So this is a turning point. At this point is a local maximum because the second derivative is negative, you can see, and at this point first derivative is equal to 0. So this is the last one. If first derivative is equal to 0 and second derivative is also equal to 0, then f has a stationary point of inflection. So this is a positive graph, negative graph. Now this is a stationary point of inflection, and as well in this graph this is a stationary point of inflection, because a stationary point that is also a point of inflection is neither a local minimum nor a local maximum. So this one is stationary point as well as point of inflection. So this is a turning point as well as point of inflection, neither a local minimum here nor a local maximum here, where a turning point that is also a point of inflection, so we called turning point of inflection, or you can say stationary point of inflection. Now I'm gonna implement these concepts in one example. I'll show you how to apply these concepts on questions. So now this is an interesting question. Sketch alongside shows the graph, and first question says we need to find the stationary point, turning point, and the second question we need to classify, which means use the second derivative test to determine the local minimum and the local maximum. Third question says to determine the point of inflection, and the last question for which values of xf is increasing, decreasing, concave up and concave down. I'll show you now how to solve these questions. So first of all, I need to find the turning point according to the question. So I'm going to take the first derivative, because to find the turning point or stationary point, first derivative must be equal to 0. Then you solve for x. Then you have to put back that x value into original function to find the y value. So the first derivative is going to be a negative 6x square plus 3 times 2 is 6x plus 12. Now first derivative must be equal to 0. Solve for x. So the negative, whenever you see the coefficient is negative, the leading coefficient is negative, then you have to multiply inside. So this is going to be a 6x square, positive become a negative 12 is equal to 0. Now I can see leading coefficient is 6 and whole trinomial can divide by 6, so that's why we divide by 6 whole trinomial. The answer is x square negative x negative 2 is equal to 0. Now we're going to factorize. X negative 2 and x plus 1 is equal to 0. After I factorize, this is my answer. Now I'm going to solve for x. X going to be equal to 2, or x going to be equal to negative 1. Now I need to substitute back into original function to find the y value. So I substitute x equal to 2 into original function to get the y value. So the first y value is 20, and then x equal to -1. I substitute into original function to get the second y value, which is -7. So therefore, the turning point is 2 and 20, and the second one is -1 and -7. This is the first question answer. According to the second question, I need to classify each of the turning points that you have calculated now as a local minimum, local maximum, or stationary point of inflection. So we're gonna use the second derivative test to determine the local minimum and local maximum. So always, sometimes they will ask you the question classify, sometimes they ask you use the second derivative test. So same thing, have a look here. So second derivative test we're going to apply here to find out local minimum and local maximum. So I have to take the second derivative to determine the local minimum and the local maximum. Remember, the first derivative must be equal to 0, and the second derivative must be either positive or negative. Then we can classify if it is local minimum or local maximum. Use the second derivative test. So the first derivative is, we apply the second derivative here to find. So 2 times 6 is -2, -12x, -12x, and then apply the second derivative here is going to be 6. So plus 6. Now second derivative we find, now we finish find the second derivative. Now we got x equal to, by the stationary point, x equal to 2. For first we're going to substitute into the second derivative x equal to 2. So second derivative, put the 2 inside, -12, 2 plus 6. So now answer is gonna be a -18, and which is less than 0. So which means, therefore, f has a local maximum at x equal to 2. Why? Because second derivative is negative. When you see the second derivative is negative, then f has a local maximum. Now we're gonna put at x equal to -1 into second derivative. -1 is equal to -12, -1 plus 6. We simplify with the calculator. The answer is positive 18, which is greater than 0, which means positive. And if you see the second derivative is positive, then which means f has a local minimum. Therefore, f has a local minimum at x equal to -1. So this is my final answer. So there is not gonna be a stationary point of inflection, because only stationary point of inflection gonna be there where a stationary point that is also a point of inflection. Now this is first, the second derivative is negative, that's why local maximum, and the second derivative is positive, so that's why f has a local minimum. So the point of inflection gonna be somewhere here, concave up, concave down. Somewhere here it's gonna be a point of inflection. So we will find out now where is a point of inflection. Now we need to find the point of inflection. So the point of inflection, second derivative must be equal to 0. We have the second derivative, -12x plus 6. So second derivative must be equal to 0, and then we need to solve for x. So the second derivative we have -12x plus 6. negative 12x, and this had become negative 6. We need to solve for x, so therefore x gonna be negative 6 divided by negative 12, so the x gonna be a 1 over 2. So therefore x value is 1 over 2. Now we need to find the y value, so we have to put this x 1 over 2 back into the original function to get the y value. So f of 1 over 2. So the original function we have, remember this is the original function, we're going to substitute that 1 over 2 into this function to get the y value. So I substitute x equal to 1 over 2 into original function, I get the y value 13 over 2. So therefore point of inflection is x value is 1 over 2 and y value is 13 over 2. So the graph is increasing from this turning point up till that turning point, graph is increasing. So the first question answer is between negative 1 and 2, the graph is increasing. Obviously negative 1 and the positive 2 is included, that's why I underline. Second question, where is f is decreasing, and the graph is decreasing. I'm gonna use the blue color. This is decreasing, and that's where the answer gonna be x less than negative 1. Left hand side all the value, the graph is decreasing, and then x greater than 2, also right hand side all the value, right hand side the graph is decreasing from the turning point. So first is where f is increasing, the second is where f is decreasing. So the decreasing x less than negative 1 is included, or x greater than 2 as well, the 2 is included. Now the third question answer is where is concave up. So the graph concave up, x less than 1 over 2. From the point of inflection we're going to give the answer, the graph concave up. And let me choose another color, and from here concave down. From the point of inflection we're going to give the answer, the graph concave down, x greater than 1 over 2, the graph is concave down. Please like and subscribe my channel. If you have any question, comment below, I will assist you. Have a nice day.